Hi all, welcome back to our YouTube channel. Topic that we will have today is efficient frontier only, but it's using Python today, not Excel like we did last time. So let's start. Yeah, before we go ahead, please, it's at our institute, we stimulate thought process to enhance your learning. So strong request to you all to subscribe to our channel, like and comments as well. So as I said that today we will demonstrate efficient frontier using coding in Python. So why Python? Because being FRM candidate, if you know bit of coding also, it gives you added advantage in your career. And yes, there is a lot of demand for blend of risk and tech professionals in the market. So yeah, you might be excited to see efficient frontier in Python. So let's have a look. So if you recollect, last time we did calculate it on Excel. We took monthly prices of Ambuja Cement and Godrej Properties. We calculated monthly returns for both. We took random weights. So initially 100% to Ambuja, 0% to Godrej. We calculated portfolio returns if we keep these weights, and risk if we weight combination is this. And likewise, we did for all the various combination, and we calculated, of course, there was a process. We use these formulas. I'll not go into those details. You can see the previous video for that. And yeah, this was a graph that we come up that we came up last time. So if I'm not wrong, it was 8.65 and 1.07. That was a portfolio with the minimum variance. Now I think there is some issue because yeah, I was just experimenting. So last time it was population variance. So if you notice, now our efficient frontier will show you. I'll demonstrate why I had changes to sample standard deviation after we explore it in Python. So this was a minimum global variance portfolio. Let's see now how it turns to be in Python. So see, this is something which which are called libraries which are available in Python. So we initially download libraries to work do our working. So these are the three libraries, and there is one fourth also to have some visualization. So both stock prices, Ambuja and Godrej properties, were taken, and daily returns. So this particular cell is calculating these daily returns. Sorry, these are prices. These are the returns that are getting calculated in this. And likewise, we needed these four parameters: uh, average returns for this time window, average return almost for a year, standard deviation, correlation. So these are the five parameters that are getting calculated over here. This is a bit tricky. People from engineering background will understand. So this is for just generating a sequence of this column, and likewise this E is a sequence to generate these weights, and F is basically to calculate. So I may be going fast, but trust me, if you code in Python on own, these take good amount of expertise and time. So this is a return of portfolio. Finally, we have G, wherein we have risk of portfolio. It's the same formula that I have used in Python. There are libraries which can make your life easy, but to demonstrate fundamentally, I have used these dictionaries. And finally, yes, to plot this, it's the same shape you can see over here. So, but over here you will notice that uh, minimum minimum variance portfolio, global minimum variance portfolio, you can say it has a variance of 9.104, and yeah, variance of 9.104. Why it is so? Because I think in our working we took a standard deviation of population, whereas it should be standard deviation of sample. So if we change this, if you now notice, it will also give you the same result that we are getting in Python. So it's 9.04, and let me just go a bit up if I can get same. So 9.04 and 9.04 and 1.13, the lowest standard deviation and highest return in this. Similarly, if you notice here, it's 9.04 and 1.13. So yeah, this was something I wanted to share and motivate you to explore on Python bit as well. Hope you like the video. If yes, please do share with your friends, colleagues who are pursuing risk, and they also have the plans to explore on Python bit. Thank you. Stay connected.